Okay, I'm going to do the 1D3 question quiz using graphs this time. I made another video using the kinematic equations. So we've got a child on a skateboard who crosses a line on a sidewalk, traveling with a speed of 2 meters per second when he begins accelerating at a constant rate of 2 meters per second squared. What will be his speed after 3 seconds? Okay, so I'm going to make a VT graph. And so I know he is going to start at 2. And I know after that, he's going to accelerate 2 meters per second squared. So 2 meters per second every second. So after 1 second, he's going to be at 4 meters per second. After 2 seconds, he's going to be at 6 meters per second. And after 3 seconds, he's going to be at 8 meters per second. Okay, so this, there you go. That's the first one. Okay, let me copy and paste this graph to my next slide. Maybe. There we go. Okay, here's the next one. So we know that it's the same setup. We just want to know how far past the line on the sidewalk the child will be after 3 seconds. So what we are going to do is we're going to calculate the area under this graph. So this is the graph right here. So this is a trapezoid, and we can divide it up into a triangle and a rectangle if we want. So this bottom one is a height of 2 and a base of 3. 2 times 3 is 6. The triangle has a base of 3 and a height of 2 to 8, which is 6. And we do 1/2 times 3 times 6, so that's 9. Okay, and so we get that our position, our displacement is 9 plus 6, which is 15 meters. The only thing we need to do, double check that we didn't have an initial starting value, because this just tells us change in position. And so if we had maybe started with an initial position of like 10, then we would be going 15 past 10, which would give us 25. But it says crosses a line on the sidewalk. How far past the line on the sidewalk will they be? So we started at the line and we're 15 meters past that. Great. Okay, last one. How long would it take a car starting from rest and accelerating in a straight line at 5 meters per second squared to cover a distance of 200 meters? So again, I'm going to use a velocity time graph because I know enough about the acceleration to draw the graph and then enough about the graph itself to find position. So we've got, we start from rest, so our initial velocity is 0, and then we go 5 meters per second squared, right? So really, 1, 2, I'm just going to sketch the graph real quick up to 4, right? So we know when it's going 4, let's see, so we start at 0, we know we're at 5, then we're at 10, then we're at 15, and then last we're at 20. Okay. Let's write down this is 5, 10, 15, so you guys understand. All right. I'm kind of in a straight line, and that's just going to keep going. Okay. This is probably the hardest one to do with the graph, but hey, whatever, we'll do it. Okay. And so we know that area under this graph is going to be our displacement, and we need to figure out when would they have a displacement of 200 or a change in position. When would the position change by positive 200? So we know that we've got 1/2. The area here would be 1/2 times the time. And then our height here is our velocity, right? And our velocity at any given time is just the acceleration times the time. So our acceleration is 5, and our time is going to be t. So really what we get is that our area of 200, we want our area to be 200, and that's 1/2 times t times 5t. 5t is, again, the vertical, is the velocity. Okay, so this gives us 2.5 t squared, and that's equal to 200. So if you divide 200 by 2.5, you get that t squared equals 80, and you get that t equals 8.9 seconds. and 8.9 seconds, I believe, on the quiz rounded up to 9.